Hey, pre-calculus, I just want to touch base and give you a shout out if you have been missing class. This video is for you, so I'm going to do the notes of what we did today with hyperbolas. We will have a quiz, but not our next time that I see you, but on Friday/Monday. Then next week on Thursday. Friday is your test. There's your heads up, and Tuesday we have a special day. I will try to mention that in class. Tuesday is an ACT day of next week. Yeah, of next week. So anyway, without any further ado, I'm going to go ahead and get started. I'm going to flip this camera around, and I'm going to get this to where you can see what I'm writing. How's that? So, woo, hold on. It's crazy. There we go. All right, so hopefully this will catch up. There we go. And I want to make sure you can see it. All right, so we're going to start with hyperbolas. And so what I had the class to do today is I said, okay, can anybody tell me what the center of this first equation is? So I'm going to actually come down and zoom in on that a little bit better. So in this first equation, somebody shouted out, oh, the center is 0, 2. And they were right in saying so. And then they said, okay, what is the center here? And I gave them time to do it. And you're welcome to stop the video and fill in all the centers. But they are 0, -1. And be careful on this. These flipped because what's with the x produces your x value here, or the h and k. All right? And then here the x is first, so it's 2, 3. Here the y is first, so it's 2, -2. And lastly, we have 1, 0. All right? Then we had to figure out the graph. And I said, can anybody figure out the graph of number 1? And in 7th period, I actually had somebody to figure out that it was C, which was correct. All the other classes, I gave them that hint. I didn't think they would be able to get it, and somebody figured it out. All right, so if you know that's the case, then number 2 is at 0, -1. I used C already. I'll tell you what, let me just go to this one. This one is out 0, down 1. Oh, that's number 2. There's A. B is out 1, up 0. Oh, that's number 5. And D is 2, -2. Oh, there you go. D. And E is the one in the middle. Okay, then I gave them time and I said, go through and see if you can figure out what is the direction of opening. Now, I am meaning horizontal versus vertical. Okay, so we'll use H or V. So the first one is going to be number 1 on C. This is horizontal. Okay, I don't know how well you can see this, so I'm going to grab another pen and I'm going to point this out. This is opening up as if it's a parabola this way. Okay, and this side opens up as if it is going around the x-axis. So we call that horizontal. Okay, the other direction is vertical, just to point that out. All right, so A is vertical. E is horizontal. This one is more believable as horizontal as opposed to this one that's really wide. All right, but it's still horizontal. D, vertical. And 5 is vertical, or B. Okay, now I said use a highlighter. Hold on. I didn't get my highlighter out. Use a highlighter and highlight what you think caused the direction of opening. Now think about this. Here we have horizontal. Okay? I don't know how well that shows up, but I did highlight it. What causes that is the x value. Okay? The vertical is the y value being first. The x value being first for horizontal, y value being first for vertical, y value being first for vertical. Okay, so we have already got something figured out here that we did not know before we started. With that said, what I want you to do is I want you to go through on these bottom ones, and I want you to put down the center for what the center is of every one of these. And we already know what causes vertical and horizontal openings. So we're going to put that down. And tell you what, just stop the video and come back, and maybe I'll stop the video so this doesn't get too long, and you can jump in and see what the answers are so you don't watch me do all of it. Why don't you fill that out and you fill this out, and then we'll talk about I'll just do it and you can pause. Okay, this is going to be -1, -1, 1, 3, -1, -1. This one starts with Y, so it is vertical, horizontal, vertical. Okay, now this one I am going to change some colors up because I want you to see how to do this before we actually go to graph it. So to find the vertices on this, it's a little different. I want to go back real quick to see this is a vertex, this is a vertex, and it is 2 units away. So let's look at C for a second right here. Okay, this is a 4, this is a 9. Where do you think those 2 units came from? Well, we said it was determined from the x value, and these went out in an x value. It went out 2. Well, it took the square root because this went up 3. So this went to 3 if you just find the B and the A. You take the square root. So now that we have that, let's go back down to this. And let's say, all right, so if I want to find the vertex, I have to look at the Y and notice that it's a 9 on the bottom. With a 9 being on the bottom, I'm going to go to the Y over here. This is the Y value, right? So this is going to be plus or minus 3. That is our vertice because it's what comes first. So that's going to give me -1 because that part doesn't change. What does change are the Y values. -1 plus 3, 2. -1 minus 3, -4. All right, and then I'm going to show you what to do to find the covertices. The covertices, this is understood to be over 1. So the square root of 1 is 1, so this is going to mean plus or minus 1. So what doesn't change is the Y value, which is -1, -1. And over here, -1 plus 1 is 0. -1 minus 1 is -2. And that's how you figure that out. So go ahead and do the other one. X comes first. This goes to 2 plus or minus 2. So the vertices is going to be 5 and 1. 1 stays. This will go to 4. So plus minus 4. This will go to 5. -3. The value of X does not change, or the H. There you go. Does that make sense? Okay, everybody was doing good and like, yeah, I got this. And then they went to this one and they said, okay, the vertice is going to be the square root of 10. I don't know what to do. All right, well, hold on. Our Y value is going to change. We're going to have plus or minus the square root of 10. So it is okay to have an answer. Now, the X value doesn't change. The Y value is -1 plus the square root of 10. And -1 minus the square root of 10. Okay? Those really are the 2 answers. Now, if you're going to graph it, you're really going to want to know that this is plus or minus about 3.2, 3.16 to be a little bit more exact. All right, so you would need to add and subtract so you can graph it. All right, So the other piece is going to be the square root of 5 plus or minus the square root of 5. Adding it in the x direction, this would be -1 plus the square root of 5, -1 minus the square root of 5, and the -1 doesn't change for the y value. And you're done. Okay, going on to this, you can read this. I do want to point something out. There is a mistake in the wording. This says the major axis is not the transfer axis. It is. It's now. Is now the transfer axis. Okay? N-O-W. Boy, that's hard to read. Let's see if I can make that a little bit better. Now. I don't know if that helps any, but it should say now. So this is now called the transverse axis because this is what houses the vertices. Okay? That's the transverse axis. And let's get red to do the conjugate axis. The conjugate axes are now kind of like we called the minor versus major, just in that the transverse has the focus on it. It's in that same line. See the foci right here. Each one is in line with the transverse axis, and the conjugate axis only acts as a means for graphing, which we will show you that in a minute. Okay? All right. And notice the foci, these parabolic looking shapes right here open up around the focus. Okay? So, moving on. We see a hyperbolic equation here and here. There's the two equations for the hyperbolas. All right? So, what I want to point out is that in both cases, there is an A on the front side. That is because A is your leading term for each one. And it actually comes down to how the foci are found, why A actually gets to stay there and not switch places. So the center is HK for both of them. The direction of opening here, because it starts with an X, it's left to right. So that's horizontal. The direction here is like the y-axis, up and down, so it's vertical. All right, and then the vertices, notice it's the X that changes because it started with the X. Over here, it's the Y that changes because it started with a Y. Okay? Just keep that in mind. Covertices, we're adding B to its opposite one that wasn't used right above it. And now look at the foci. It's c squared equals a squared plus b squared. Now that's different than when we had an ellipse, all right? So the foci is going to be h plus c, comma k, h, and k plus c. So notice these match this one and this one almost match, except instead of adding a, we're adding c because we are no longer finding the vertex, we are finding the foci. Okay? So, which compare the ellipses. Here are the two equations, Here are the two equations for ellipses, and when we're comparing them, we're going to notice that in these two equations, for this one to be horizontal, the horizontal is going to be the one with the A on it. So that's the first one. So that's the x minus h squared plus y minus k squared equals 1 all over a squared, b squared. Okay. The next one is going to be the other one. It's x minus h squared plus y minus k squared equals 1. But this time it's going to be under the y. The a squared gets the y. Okay, and that's what makes it horizontal. So remember the difference between ellipses and hyperbolas. They're very similar. In fact, here we go. We're going to look at these differences. Now keep these two equations in mind because we're going to use these h's and k's for these two. Now, we did say this is a hyperbola, so which one is this one? It starts with x and the biggest number is a, so it's actually this one. This one right here, it starts with y, so its initial equation looks like, or generic equation, is y minus h squared over a squared minus, I almost said plus, let's fix that. Okay. And then b squared and x minus k. Oh, I just caught it. That's a y and a k and an x and an h squared equals 1. Okay, so I fixed my problem. So we're going to use this equation and this equation to talk about these. We're not actually going to use their numbers. So how do we find the center of an ellipse? Well, that's hk. How do you find the center of a hyperbola? Well, that's hk. All right. What determines the vertical versus horizontal? Well, over here, it will make it vertical if your a squared is under the y. So a squared is what determines vertical versus horizontal. Okay? A squared. It's the largest denominator. Okay? And then in the hyperbolas, what determines vertical, horizontal? It's not the biggest one. It's not A. Well, technically it is going to be whichever one A is with, because A always goes with the first one. So it is, in this case, it is the y squared value, because we have the y minus k squared. So we're looking at the first term. Put in the parentheses, first squared term. Okay, so here, vertices. All right, so how do I determine the vertices? Well, to get these vertices, I have to take, it's the x that changed, so it's going to be h plus or minus whatever a is, and then the k is there. It doesn't change. Well, look at how I get this vertice. I have that h and k again, and this time the a value is going to be this y direction here, but that's our a. It's just adding to the y. So it's going to be h and k plus or minus a. The biggest thing I want you to catch on this is that what we're adding to each part for the vertices, there is a commonality even though they're different. We're adding plus or minus a. It's just added to y in one case and x in the other, or h versus k. All right, but the h is always an x value, k is always a y value. All right, covertices. This is getting a little tight. Okay, there we go. So the covertices, we're going to find those by the b value. So whatever we used up here, h will go back to being h, but this time we're going to have k plus or minus b. Notice again, I have a b value being added in here. And look what happens for the covertices for this side. For this one, I'm going to have h plus or minus b and then k. All right, so again, it's that plus or minus b going on. Distance c for the foci. Well, this one, if you remember, is c squared equals a squared. C squared equals a squared b squared. Here's the difference. For an ellipse, this is a minus. That's why a always has to be, a squared always has to be the biggest number. Because if a squared was smaller, you would get a negative c, and we can't have a negative c. Over here, it's the opposite. It is a plus sign, which really is the Pythagorean theorem. Okay? Now, the last thing in the equation itself, well, in the equation itself, this has a plus sign, this has a minus sign, between the squared terms. Okay? So that's referring to this and that. Okay? That has a plus sign. This has a minus sign. And that's what it's referring to. What's the difference in the equation itself? Otherwise, the equations look identical. All right? And, of course, we could say a squared is always first within a hyperbola. Okay. Now, practice on graphing. Okay, in this one, I am going to change colors for all of this one. All right, and I'm going to show you the steps for graphing. First of all, for this being the equation, we need the center. The center is x is first, then y, so it's 2, negative 1. And I'm going to graph out 2, down 1. And then I'm going to say, well, what's underneath these? I need the A and the B. Well, if you'll look, you're going, there's nothing underneath it. Well, that means we could write both of them over 1. So it means A equals 1 and B equals 1. So that means we're going to add the square root of 1 to each of these. So plus or minus 1, that is. So for the vertices, that means I will have 2 plus 1 is 3 and negative 1. And then a minus 1 is going to be 1, negative 1. And the covertices, the 2 stays the same. And the 1 changes by plus and minus 1. So negative 1 plus 1 is 0. Negative 1 minus 1 is negative 2. Now I want to show you over here. I'm going to do that exact thing. I went out 1 in each direction. And notice the x was first. So these are the vertices. And then up and down 1 in each direction. And you're welcome to check these and make sure they match this. All right? Draw the box that contains them, okay? What box contains them? It's really simple. It's right here. Now, it is real important to me that I hung on to the vertice there and I plotted that. Now what I'm going to do, let me see if I have a straight edge of some kind. I have a checkbook. That will work. All right. I'm at my house and I'm in my office working. So what you're going to do is you're going to make a big line that way, you see. And then I'm going to do the same thing and connect the diagonals, make a big line this way. Hold on. Wait for it. There it is. All right. It might be ever so slightly off, but it's pretty close to accurate. This is the whole reason I wanted to do it on paper like this, because doing it on the computer is very difficult to get nice, good lines. All right, so draw the box that contains the vertices and the covertices. Did that. I did this and I did that. And now we're going to carefully choose these asymptotes. And you can see this opening up. It's going to follow the direction of the asymptotes right here. There's one of them. Here's the other one. All right, so if we've got both sides, there's our hyperbola and we're done. Okay? So find the focus. Okay, well, let's go in and find the focus on these. Well, if I find the focus, I'm going to change colors again. I'm going to use c squared equals a squared plus b squared. A squared is 1. B squared is 1, which is 1 plus 1, which is 2. Take the square root of both to solve. C equals the square root of 2, which is about 1.4. All right, so I'm going to go in here and go out 1.4, which is close to 1.5 from the original. Okay, so this little tiny blue dot right there, that's the focus. And that one is the other focus. All right? So now you have it graphed. Now, write the equations of the asymptotes. That's not so hard. You haven't done this in a little while, but this one is pretty easy. We get to use y equals mx plus b. Okay? And then what we're going to do is we're going to find what is the slope of each one. So of line number 1, y equals, this line is going down, so it's negative as we go across. Okay, as you go left to right, this line's going down. And so it's a -1 slope, so it's negative x. And then we just have to say, where is it crossing? Oh, it's right there at 1, plus 1. Line number 2, y equals. Well, this is a +1, so it's just x. And this one crosses right there at 3, -3. I'm done. Okay, there's my equations. You do 10 and 11. And I will have the key for you so you can check yourself. I will have the vertices on there. I will have the foci. And what I'm going to do is skip down here and show you how to do this bottom one. Okay? I'm going to do this one and then I'm going to stop. All right? So the easiest way to show you this one, it's located, the center is at -3, 1. Right there. That's the center. The vertex, and that should have been a little comma, and I noticed it was a point. That was a typo on my part. Sorry. So -3 up 4 is a vertex. Now that's important to know because your vertex is it's kind of like the vertex of one of the parabolas that's being formed. There's 2 parabolas in a hyperbola, right? So that's one of them that's opening up. And I really don't have to know too much about it. This is the center, and the covertice is at 0, 1. So out 0, up 1 is a covertice. So that means this would be like creating that box thing. That's the only reason we have the covertice, to get our diagonal lines. Okay? So all this is asking us to do is to write the equation. So this distance right there, that distance is A. And this distance over here is B. Okay? So, and your vertex, or your center is going to tell you what your center is, you know, what you're putting in with the X's and Y. Your vertex is going to tell you if it's the X or the Y. Okay, if this is vertical, because it's going to be opening this way, if this is vertical, then that means y has to come first. Y minus something squared over minus x minus something squared equals 1, and that's over. All right, so look what we have. We have 1 goes with a y, -3, which makes that a +3, goes with the x. Then you have to say, okay, the y is the a value, so that's 3. 3 squared is 9. B value is 3. 3 squared is 9. I'm done. Okay? So you can try the others. I will finish them out. This video is long enough.